embarrassing story I actually told them was that I graduated college in 1986, and my first job out of college actually was a company that was still using punch cards. So part of being old is I get to live in the past. And I've been a developer for 30 years, mostly because I'm a really terrible manager, so I still write code 30 years later. And being that I've been a developer so long, for me to get an interest in blockchain, there needed to be use cases that would be usable immediately. And one of the use cases that's very popular on the blockchain is food traceability. If you go out onto YouTube, you're going to see a ton of videos about product traceability and food traceability. IBM's got a big initiative with food traceability. And one of the reasons I'm interested in it is it really meets all the things that are the definition of the original Satoshi blockchain that goes back to 2009. If you look at the things that blockchain provides, the transparency, the trust, the traceability, and everything that goes along with a blockchain, your distributed ledger for secure transfer of assets, using immutable transactions, protected by cryptography, agreed upon by consensus, you actually get to give credit to Satoshi Nakamoto back in 2009. Now, the magic to the original blockchain was actually not provided by any of the things that I explained on the last screen. It was actually UTXO, the unspent transaction output model, that is what solves the double spend problem. So UTXO, the mechanism that solves the double spend problem, also has an unintended feature. Now, some people call this unintended feature a bug. There's been a lot of people who've done projects working around getting rid of transparency and traceability. The crypto note framework is built on ring signatures and single-use keys, so you can't go into something like Etherscan and see how much money I have in my Ethereum wallet. But part of UTXO and part of the original Satoshi white paper, Bitcoin.pdf, defines a coin as a chain of digital transactions. And so the input to each transaction is the output from one or more, the unspent output from one or more other transactions. And what this allows is the coins in your wallet to be traced all the way back to the miner that mined it. Again, some people call this a bug, other people call this a feature with transparency. So if we look at it, we can go back to, if I look at my Ethereum wallet or my Bitcoin wallet, with a little bit of processing power, I can go all the way back to the miners that mined the coins that are sitting in my wallet. Now, part of blockchain, and this is also part of being around and doing this for so many years, is if you have to change the definition of blockchain to fit your use case, don't go any further. So I was really interested in traceability for blockchain because it fits the definition of blockchain. We've got the string of transactions just like you would have when you're talking about farm to fork, when you're talking about trying to trace a product from the time it was on the farm to the time you actually, the birth date of your burger, let's say. So food traceability is a series of inputs and outputs just like blockchain. So from my standpoint, there was no reason to stop. We should just keep moving forward, developing a blockchain solution for food traceability. And I'm going to do this, I'm going to show how this applies with one of my favorite topics, which is guacamole. And the guacamole that I actually have on the screen from Jaffa Salads, it was actually our first client, it was our first blockchain client. This is the first guacamole on the blockchain. And it is made up of just like you would a Bitcoin transaction. Okay, when you think of guacamole, you think of that 1 pound batch of guacamole. Well, that 1 pound batch of guacamole starts out as a 455 pound batch of guacamole. And then it becomes retail packaging. So that 455 pounds of guacamole becomes 8-ounce packages, 16-ounce packages, 3-pound packages. It's also shipped to wholesalers who turn it into salads. They turn it into all these other products. They're a private labeler, which means grocery stores will take the guacamole, they'll put it in their own packaging, and they'll sell it as their own product. So this actually becomes a big deal for traceability because that 455 pound batch of guacamole came from avocados, came from onions, came from tomatoes, and this is where the real problem that blockchain solves comes in. Once or twice a year, they're going to get a call from one of their distributors that says, hey, that batch of onions you got on Wednesday, that's bad and you need to recall it. But you don't just need to recall those onions that you still have left. You have to go out and find every product that those onions were used in, which turns out to be a natural use for the blockchain. Because if I treat the asset transfer on the blockchain for onions, avocados, and tomatoes like I treat it for my cryptocurrency, I can now go into my blockchain, I can go into my ledger and find out where those bad onions ended up. Now, it looks something like this when you're all done. You've got your recipes, you've got your batches, it goes into packaging, it gets shipped out. It's a big deal, and it's one of the holy grails of food safety is to be able to transfer your product from farm to fork. So why is this a big problem? Well, according to the CDC, every year 48 million Americans are sickened by a foodborne illness. Okay, globally, it affects over 600 million people, and the problem causes between 55 and 90 billion dollars in economic loss each year. The worst thing that can happen to especially a smaller mid-sized company is when you get that call that says you have to go out and do a recall. And what the blockchain allows us to do is make that recall much less damaging to everybody involved. So if those onions got recalled and within minutes I can determine every place those onions ended up, we've solved a huge economic problem with the blockchain, and not just with the blockchain, but with the 2009 Satoshi blockchain that is basically basing everything on UTXO. So there's also a couple of other advances that were necessary. We needed to be able to identify other non-monetary assets. We needed to track both inputs and outputs because you need to trace both ways. If someone gets sick in, let's say San Francisco from an item, you need to figure out, you need to trace it back to where the source was. So you need to be able to track inputs and outputs. And then we needed to add key value stores and indexing for rapid query of specific assets on the blockchain. Because you can't just query any Bitcoin, you actually have to get the lot of onions that went bad. So the nice thing about this is that there are industry standards. And if you're in data science, the greatest thing is when you have numbering that goes across an industry. So GS1 is the standards body for manufacturing of food service industry. It creates a numbering standards that are unique worldwide. So if you're doing a public blockchain, you can then having numbering standards that you can put in the blockchain to find things is a huge win, and they're solving a lot of the development products just by having standards. So if we look at this illustration, we look at how the different numbering, where you've got a GTIN, which is the Global Trade Identification Number, Global Shipment Identification Number. It looks a lot like a Bitcoin, moving across from person to person or from company to company. What we work with our food ledger and with our traceability blockchain is a public blockchain. Public blockchains are a great thing for something like this because it reinforces no central authority, it reinforces trust and transparency. You don't have a central authority that is telling you how you should manage your data. It provides a lot of opportunities for new technology, and it keeps data off the blockchain that doesn't belong there in the first place, okay? So we don't care if the onions were paid for. We don't care if they got the best price of the onions. We don't care if they use cryptocurrency to pay for the onions. We just need to know that those onions went bad, and we need to find where they went. So there's a lot of issues solved by the modern blockchains that aren't really necessary for the traceability blockchain. So if I look at our blockchain block explorer, you see that it's a bunch of hashes. So people get real nervous when you talk about public blockchain. I know that some of the big companies are pushing these permission blockchains, but this data isn't useful to anybody. So when you look at our block explorer and you say, well, I've got this asset and it moved from this location to this location, it's great for data scientists because they can do aggregation of data, but it's not like proprietary information that businesses need to worry about. So like when we look at transactions, it's kind of the same thing. Now, one of the things that's different in traceability is a lot of times you're transferring an asset to yourself. So I'm transferring onions to guacamole, I'm transferring guacamole to salad, and then finally I'm transferring the salad to another person. So there were some things that we had to solve for traceability, but for the most part, I'd say 95% of it was solvable using the principles from Bitcoin.pdf, which was published in 2009, which when you're somebody who lives in the past, it's a great thing. So what this does for everybody else is it creates advancements for data scientists. It creates advancements for other types of businesses. You would assume that manufacturing companies have their act together. Well, we found they really don't. Things like RFID, barcoding, IoT, better ways of improving data quality, better ways to analyze the data. We treat blockchain as a source of data that can be used by others instead of a consumer of data. We're creating a lot of data. It's amazing how much data gets created when you're moving food to all the different locations it goes. But it's opening up a lot of advancements that we hope that others will take advantage of, because as we're just focusing on making sure people don't get sick using the blockchain, there's so many opportunities that we hope other people in data science take advantage of. And, oh, by the way, there is fun. We actually have an app on the iPhone store. If you really want to know where your burger was born, most end users really don't care that much about it, but our clients love it. They love the idea that we could put a UPC code on a product and they can go into the app and they can see all the places where all the ingredients come from. It's one of those things that's fun, although, you know, from a data science standpoint, we did it because our clients want it. And if you want more information, you can go to traceabilityblockchain.org. It kind of talks about everything we're doing. Again, we are kind of old school. We built blockchain to have customers pay us money. So we didn't build blockchain for coins. We just want customers. So thank you very much.